The video you are about to watch is STS-119, ISS Assembly Flight 15A, was a Space Shuttle mission to the International Space Station, which was flown by Space Shuttle Discovery during March 2009. It delivered and assembled the fourth starboard integrated truss segment, and the fourth set of solar arrays and batteries to the station. The launch took place on 15 March 2009, at 7:43 Eastern Time Zone. Discovery successfully landed on 28 March 2009, at 3:13 p.m. Eastern Time Zone. Please let's take a moment and remember this American icon. The Space Shuttle is a retired partially reusable low-Earth orbital spacecraft system operated from 1981 to 2011 by the U.S. National Aeronautics and Space Administration, NASA, as part of the Space Shuttle program. Its official program name was Space Transportation System, STS, taken from a 1969 plan for a system of reusable spacecraft, where it was the only item funded for development. The first of 4 orbital test flights occurred in 1981, leading to operational flights beginning in 1982. 5 complete Space Shuttle orbiter vehicles were built and flown on a total of 135 missions, from 1981 to 2011, launched from the Kennedy Space Center, KSC, in Florida. Operational missions launched numerous satellites, interplanetary probes, and the Hubble Space Telescope, HST, conducted science experiments in orbit, participated in the Shuttle Mir program with Russia, and participated in construction and servicing of the International Space Station, ISS. The Space Shuttle fleet's total mission time was 1,322 days, 19 hours, 21 minutes and 23 seconds. Space Shuttle components include the Orbiter Vehicle, OV, with 3 clustered Rocketdyne RS-25 main engines, a pair of recoverable solid rocket boosters, SRBs, and the expendable external tank containing liquid hydrogen and liquid oxygen. The Space Shuttle was launched vertically, like a conventional rocket, with the 2 SRBs operating in parallel with the orbiter's 3 main engines, which were fueled from the external tank. The SRBs were jettisoned before the vehicle reached orbit, while the main engines continued to operate, and the external tank was jettisoned after main engine cutoff, and just before orbit insertion, which used the orbiter's 2 Orbital Maneuvering System, OMS, engines. At the conclusion of the mission, the orbiter fired its arms to deorbit and re-enter the atmosphere. The orbiter was protected during re-entry by its thermal protection system tiles, and it glided as a spaceplane to a runway landing, usually to the shuttle landing facility at KSC, Florida, or to Rogers Dry Lake in Edwards Air Force Base, California. If the landing occurred at Edwards, the orbiter was flown back to the KSC atop the shuttle carrier aircraft, a specially modified Boeing 747. The first orbiter, Enterprise, was built in 1976 and used in approach and landing tests, but had no orbital capability. 4 fully operational orbiters were initially built: Columbia, Challenger, Discovery, and Atlantis. Of these, 2 were lost in mission accidents. Challenger in 1986 and Columbia in 2003, with a total of 14 astronauts killed. A 5th operational, and 6th in total, orbiter, Endeavour, was built in 1991 to replace Challenger. The Space Shuttle was retired from service following Atlantis's final flight on July 21, 2011. The US relied on the Russian Soyuz spacecraft to transport astronauts to the ISS from the last shuttle flight, until the launch of the Crew Dragon Demo 2 mission in May 2020. Historical background: during the 1950s, the United States Air Force proposed using a reusable piloted glider to perform military operations such as reconnaissance, satellite attack, and air-to-ground weapons employment. In the late 1950s, the Air Force began developing the partially reusable X-20 Dinosaur. The Air Force collaborated with NASA on the Dinosaur, and began training 6 pilots in June 1961. The rising costs of development and the prioritization of Project Gemini led to the cancellation of the Dinosaur program in December 1963. In addition to the Dinosaur, the Air Force had conducted a study in 1957 to test the feasibility of reusable boosters. This became the basis for the Aerospace Plane, a fully reusable spacecraft that was never developed beyond the initial design phase in 1962-1963. Beginning in the early 1950s, NASA and the Air Force collaborated on developing lifting bodies to test aircraft that primarily generated lift from their fuselages instead of wings, and tested the NASA M2F1, Northrop M2F2, Northrop M2F3, Northrop HL-10, Martin Marietta X-24A, and the Martin Marietta X-24B. The program tested aerodynamic characteristics that would later be incorporated in design of the Space Shuttle, including unpowered landing from a high altitude and speed. Approximately 4 hours prior to deorbit, the crew began preparing the orbiter vehicle for re-entry by closing the payload doors, radiating excess heat, and retracting the Q-band antenna. The orbiter vehicle maneuvered to an upside-down tail-first orientation, and began a 2 to 4 minute OMS burn approximately 20 minutes before it re-entered the atmosphere. The orbiter vehicle reoriented itself to a nose-forward position with a 40 degrees angle of attack, and the Forward Reaction Control System (RCS) jets were emptied of fuel and disabled prior to re-entry. The orbiter vehicle's re-entry was defined as starting at an altitude of 120 kilometers, when it was traveling at approximately Mach 25. The orbiter vehicle's re-entry was controlled by the GPCs, which followed a preset angle of attack plan to prevent unsafe heating of the TPS. The GPCs also controlled the multiple aerobraking S-turns, using only the roll axis, to dissipate excess speed without changing the angle of attack. The orbiter vehicle's aft RCS jets were disabled as it descended, and its ailerons, elevators, and rudder became effective in the lower atmosphere. At an altitude of 46 kilometers, the orbiter vehicle opened its speed brake on the vertical stabilizer. At 8 minutes 44 seconds prior to landing, the crew deployed the air data probes, and began lowering the angle of attack to 36 degrees. The orbiter's maximum glide ratio lift-to-drag ratio varied considerably with speed, ranging from 1.3 at hypersonic speeds to 4.9 at subsonic speeds. The orbiter vehicle flew to one of the two heading alignment cones, located 48 kilometers away from each end of the runway's centerline, where it made its final turns to dissipate excess energy, prior to its approach and landing. Once the orbiter vehicle was traveling subsonically, the crew took over manual control of the flight. The approach and landing phase began when the orbiter vehicle was at an altitude of 3,000 meters and traveling at 150 meters per second. The orbiter followed either -20 degrees or -18 degrees glide slope and descended at approximately 51 meters per second. The speed brake was used to keep a continuous speed, and crew initiated a pre-flare maneuver to a -1.5 degrees glide slope at an altitude of 610 meters. The landing gear was deployed 10 seconds prior to touchdown, when the orbiter was at an altitude of 91 meters and traveling 150 meters per second. A final flare maneuver reduced the orbiter vehicle's descent rate to 0.9 meters per second, with touchdown occurring at 100-150 meters per second, depending on the weight of the orbiter vehicle. After the landing gear touched down, the crew deployed a drag chute out of the vertical stabilizer and began wheel braking when the orbiter was traveling slower than 72 meters per second. After the orbiter's wheels stopped, the crew deactivated the flight components and prepared to exit. The primary Space Shuttle landing site was the Shuttle Landing Facility at KSC, where 78 of the 133 successful landings occurred. In the event of unfavorable landing conditions, the shuttle could delay its landing or land at an alternate location. The primary alternate was Edwards AFB, which was used for 54 landings. STS-3 landed at the White Sands Space Harbor in New Mexico, and required extensive post-processing after exposure to the gypsum-rich sand, some of which was found in Columbia debris after STS-107. Landings at alternate airfields required the shuttle carrier aircraft to transport the orbiter back to Cape Canaveral. In addition to the pre-planned landing airfields, there were 85 agreed-upon emergency landing sites to be used in different abort scenarios, with 58 located in other countries. The landing locations were chosen based upon political relationships, favorable weather, a runway at least 2,300 meters long, and taken air DME equipment. Additionally, as the orbiter vehicle only had UHF radios, international sites with only VHF radios would have been unable to communicate directly with the crew. Facilities on the east coast of the US were planned for East Coast abort landings, while several sites in Europe and Africa were planned in the event of a transoceanic abort landing. The facilities were prepared with equipment and personnel in the event of an emergency shuttle landing, but were never used. After the landing, ground crews approached the orbiter to conduct safety checks. Teams wearing self-contained breathing gear tested for the presence of hydrogen, hydrazine, monomethylhydrazine, nitrogen tetroxide, and ammonia to ensure the landing area was safe. Air conditioning and freon lines were connected to cool the crew and equipment and dissipate excess heat from re-entry. A flight surgeon boarded the orbiter and performed medical checks of the crew before they disembarked. Once the orbiter was secured, it was towed to the OPF to be inspected, repaired, and prepared for the next mission. The Space Shuttle retirement was announced in January 2004.